tasks, integrating some of the work that we've already conducted to create the results, which I'll be sharing with you today. Bruce, why don't you go next?
Hi, I'm Bruce Winchester. I'm the Executive Director of the Canadian Natural Gas Vehicle Alliance. We are the lead organization on this project. Of course, we are ably and effectively assisted by Clear Seas, who are working on these last two tasks of the report, and as well by Vard Marine, our marine architect experts, and they have been quite instrumental in the development of the first, what are we, six? Is it first 6 or 7? What are we at? 6 chapters, right? Correct me if I'm wrong. Megan's nodding. Good, excellent. Apparently, it's too early in the afternoon for me to remember how many chapters we have. This is a report that's very much driven by participation, by your input and input of others. So it's fairly important as we get to these last 2 tasks that we're able to, as Megan says, gather different perspectives and perhaps even share a little bit of the information that we've collected so far. First 6 chapters are fairly strongly technical and rooted in existing maritime technologies, existing knowledge of where vessels travel primarily in the Canadian Arctic region, and again reflecting the state of play of current technologies available both for liquefied natural gas production, storage, distribution, supply chain issues, as well as use of liquefied natural gas on maritime vessels. And all of that is fairly technical. We started to do a little bit of an overview into what kind of infrastructure might be required. So it was a little more technical. So we're going to build on that technical development. And we also held a perspective gathering workshop back in January. So we are again picking up on that work that we had done previously. And so I am looking forward to hearing feedback from this group and perhaps others who may be added to this group. And we may even have some additional one-on-one conversations to help us gather as much information as we can to make this report as effective and relevant both for Canadians at large and Northerners in particular. So those who live in the Arctic regions and other northern parts of Canada that are, if not necessarily Arctic, in an Arctic-like direction. So I will try to say as little as possible because I'm known to speak too much. I'll hand it back over to colleagues at Clear Seas who've got a great program set up for today. And I think have been working away on some outlines for the key themes in this chapter. Thank you.
Thanks, Bruce. Before we get into that, I'd love if we could just do a quick round of introductions, and I'll ask each person to share their name and organization and affiliation, and maybe just anything you're hoping to see out of today's meeting, and then we'll dive into the content. So I can see if you don't want to share through speaking, feel free to put that in the chat, and I can share on your behalf. But if you would like to just go ahead and speak, please feel free to unmute yourself. I can call on people if that's something you're comfortable with. Motwakil, you just put something in the chat, so I can either read that out. Oh, technical difficulties with audio and video. So I'll read that out on your behalf. Motwakil Adoma is the Senior Advisor of Petroleum at the Government of Nunavut in the Department of Economic Development and Transportation, and recently joined the Government of Nunavut. So, but unfortunately having some technical difficulties with audio and visual today. So we appreciate you being here to take part, and feel free to use the chat anytime you'd like to ask a question or share a point, and I will be happy to relay that on your behalf. Is anybody else would like to introduce themselves? Feel free to just go ahead and unmute, or the chat is also an option.
Well, excuse me, Lauren Brown here, Government of Northwest Territories, Department of Infrastructure, and I'm just listening in today.
Thank you, Lauren. Delia, would you?
Hi.
Or yeah, please, on the phone, go ahead.
Sorry, Delia, I didn't mean to cut you off. It's Jeff Maurice here from Nunavut Tunlavik in Iqaluit. Glad to participate in the call today.
Thanks, Jeff.
No problem, Jeff. You didn't cut me off. Anyway, Delia Chesworth. I'm the ADM of Programs and Services, Government of the Northwest Territories. Like Lauren, just here to listen, but quite intrigued by the discussions around the infrastructure element.
Thanks so much, Delia. Karen, go ahead.
Thank you very much. When there was this earlier discussion back in January, Colleen Parker from the Nunavut Marine Council participated. She is away right now, so I'm kind of participating in her stead. There may be another person from the Nunavut Impact Review Board who may join to listen. As someone who would be, as an organization that would be doing any type of reviews of any activities, we're really looking to listen and acquire knowledge about what may or may not be happening. So thank you very much for the opportunity to listen, and we'll ask questions as needed.
That sounds great. Thank you, Karen. And I think Danielle, if you'd like to introduce yourself. Oh, microphone is unavailable for Danielle. Would you like to put your details into the chat, Danielle, and I can share them for you? I'm not sure if there's anything I can do about the microphone. Danielle, feel free to put things in the chat if you'd like to share any time. But in the meantime, I think I will hand over to Paul to share some of the content that we'd like to go through today. And I will encourage people to stop and ask questions at any time if they would like to clarify a point or share a perspective. And this is intended to be informative, but also seeking information back from you as well. So over to you, Paul.
Sounds good. And can I get a thumbs up that that's working? You can see the screen. Fantastic. Okay, thanks everybody. And it's great that you can join us. I think you're joining, don't be alarmed by the fact that this says task 7, 8. I think you're joining at a great time. And I'm going to assume that everybody on the call has very little knowledge of what has happened to date. So we'll be bringing everything up and integrating all the work that's been done up till now to help put this together. So briefly, I think you saw in the briefing what we're about here. This is intended to look at what will happen if we replace heavy fuel oil and diesel in the Arctic with natural gas in the form of LNG or liquefied natural gas. And the intention here is to do an assessment of its impact primarily on ships and shipping, but we are looking at on the side potential side benefits in terms of fuel switching of diesel as a fuel for power generation in the Arctic as well. And you see there some of the potential benefits: oil spill risk reduction, obviously, black carbon emission reduction, potential sulfur emissions, greenhouse gas emissions reduction potential, the potential for reduction of the impact on people's health, and on the natural ecosystem and fuel supply and food supply. And then also as a component of meeting 2050 net zero objectives for government. So the intention of this project is to provide an assessment of what potential does natural gas offer in terms of addressing these opportunities. What risks does it present along the path? Does it offer a compelling option to any of these problems is the intention. I think Bruce mentioned some of those that have participated in the project up until today. You'll see some of the organizations that you're part of in this list. What I would encourage you to do is to review the perspective sharing workshop. I think Karen mentioned this was held in January. It's recorded and it's broken up into segments. This was a great opportunity to get caught up on the work that was done in the first half of the project. And so all the presentations are recorded or available for download. So if you want to see what other people have been saying about the project, I encourage you to take a look over there. But the project's divided into task teams. We're talking about tasks 7 and 8. So the first tasks were labeled 1 through 6. 1 was about technology readiness, which we'll talk about the kind of ships that could use or are starting to use natural gas. Task 2 and 3 were what the economic benefits and the environmental risks and benefits of adopting natural gas if those ships do convert to natural gas. Task 4 talked about the infrastructure options for how gas could be provided to those ships, particularly in the Arctic. And then task 5 and 6 assessed some of the human resources. So in terms of, for instance, training that might be required or skills that might be required. And task 6 talked about regulatory challenges. So relating to certification and permitting and questions associated with that. So tasks 7 and 8, what we're here to talk about today, it ties a bow around the complete project and intends to talk about how might this look in task 7, and task 8 talks about what would the potential impact be, and summarizing all of the conclusions of the work to date. We're taking a fairly neutral view on task 7 in terms of implementation scenarios. We're basically saying if the kinds of ships that we've seen start using natural gas, what will the consequence be? We're not advocating in any way that they should. We're just saying, because we're already seeing signs that some of ships are adopting natural gas. And so the intention is to say, if all the ships that could burn natural gas begin using it as a fuel, what would the implications be? So that's kind of the take on in task 7. So the scenarios are to say what would happen if we did that, how much fuel would they need, where would they need it, what would the emissions impact be on emissions in the Arctic, both greenhouse gas and other pollutants. And then task 8 will be more of a narrative summary of all of the findings. So it's all of the conclusions that were reached all the way through the project. So I'm going to put up an outline of what we're proposing that the structure of these tasks will be. So task 7 would be probably more numbers, and not task 8 would be more words in some simple sense. Although we've done some very detailed analysis to date at an individual ship level in tasks, particularly task 1, 2, and 3, we haven't yet looked at the Arctic as a whole in terms of the emissions that take place in the Arctic from shipping. And so the first job in task 7 is to look at how much fuel is used for different kinds of shipping and what are the emissions from that shipping as a whole, because that's the baseline from which any changes might occur if the fuel is switched. So I'm going to talk to you today about some of the data that we've managed to extract in terms of giving ourselves a baseline as to what the current state of emissions from shipping are. and then look at what kinds of ships might switch fuels, and is roughly divided into domestic shipping, so ships that carry out the annual sea lift for fuel and goods. International shipping, these are mainly bulk carriers that come and pick up oil from mines, and then government ships like icebreakers. Then, based on the work that we was done in task 3 in terms of the emissions from ships, the changes in emissions by fuel switching, we can basically calculate what the impact on the emissions in the Arctic as a whole could be. That's point 3 of task 7. And then task 4 says, well, if all those ships were burning natural gas instead of oil, how much fuel would they need and where would they need it? And how does that compare to the amount of LNG that's available at those places? So that's the kind of, so it's quite number intensive, but it is looking at what are the kind of, to give a feel for both the emissions and economic impacts in numbers for the Arctic as a whole. And then task 8 kind of ties that all together under 2 broad categories, environmental and economic. So the environmental impacts, looking at the air pollution and health benefits of the reductions that we've calculated in task 7. Looking at the greenhouse gas benefits, so the CO2 and black carbon reductions that are being calculated in task 7, but also address the question of the risk of increase in methane emissions, particularly from some particular types of engines, the low pressure dual fuel LPDF engines, and reduction in venting of methane, because methane, as we know, is a greenhouse gas. Also summarizing some of the work done in the earlier tasks on oil spill risk reduction. Obviously, LNG isn't oil, so there's a major reduction in oil spill risk, and even further reduction compared to diesel. So that would be summarizing that. And then the economic impacts. So we've calculated in task 2 the kind of business case for an individual ship level. It says, if you were a ship owner, would there be a business case and a payback period for you to switch fuels? Because of course LNG can potentially be cheaper than alternatives. This takes a more kind of broader economic impact question look. So it says, well, what could the potential economic benefit be in terms of goods transportation cost? So what is the cost of transporting goods into the Arctic using diesel fuel versus natural gas? What is the value of natural gas that would be sold as a fuel? So instead of you buying oil-based fuels for LNG, what would the revenue generated, the size of the business of the LNG that would need to be supplied? What is the size of the infrastructure based on some of the work that was done in task 4? So if natural gas infrastructure needed to be constructed to supply these ships that were starting to use natural gas, how much would that cost, and how much would that be valued at in terms of investments in various regions? We would re-summarize some of the work on the cost and potential business opportunities for those involved in the ship conversion or construction business. Looking at the size of the fleet that uses that could be converted or new constructed, and then if possible, we will try and take a look at as I mentioned, some of the side benefit of having natural gas available in the region would be a competitive a reduction in energy cost for electricity, because natural gas can be cheaper than diesel, and since diesel is currently the primary source of electricity generation, an assessment of what the potential benefit in terms of electricity cost reduction for the region might be. So I'm going to stop perhaps there and pause and see if there are any clarifying questions before I carry on, because what I have available in the presentation is the preliminary findings from task 7 which I could show you, so it might help to see what some of the conclusions would be. But I will pause there and see if there are any questions before we carry on.
We do have one question from Delia. Are you looking at cruise ships for tourism?
Yes, cruise ships are included in the scope, and I'll show you the conclusions and make sure that we focus on them a little bit.
And I just want to take a moment to welcome Heather Rasmussen, who's just joined us. Great to have you here, Heather. And Paul's just been giving us an overview of the work that's been done to date. And a couple of things we'll just mention very quickly is if you're interested in or missed anything in the past in this project, the previous 6 segments of work, we encourage you to go to the Clear Seas website, and there is a perspective sharing workshop there with presentations and recordings, and a lot of different topics have been covered there. So if you wanted to find a way to catch up, and then we're just taking a pause here for questions. And so if you'd like to take a moment to introduce yourself, your organization and affiliation, and anything that you're particularly interested in today's discussion, that would be great. And then we'll move into see if there's any other questions.
Was that a question to Heather?
Yes, Heather, if you would like to introduce yourself, or if you're like some of our other people here who've got some issues with audio or visual, feel free to drop any details into the chat, and I would be happy to share them on your behalf.
Okay, I'll call up the chat, and feel free, because I'm not looking at it currently, but
I'm happy to manage the chat.
Okay,
Paul, if you want to.
You want
to keep on with the
so I'll keep going, but feel
Yeah.
free to post things in the chat if you want to. So what I'm going to show you next is kind of where are we getting some of the data to help put the context of what emissions and what fuels and what emissions do ships that come into the Canadian Arctic currently use, and how might that change if they switch fuels. So one tool that we plan to use quite extensively is the Marine Emissions Inventory tool. This is something that Environment and Climate Change Canada provide. It allows you to get an assessment of the emissions of shipping. What it does is it takes the position of ships and the kind of ships that and how far they travel in regions of all the regions of Canada, and then it uses emissions factors to calculate what the emissions most likely are based on those assumptions. And you can look back, I think, from 2015 to 2019. It's categorized by regions there, so you can see the regions highlighted represent quite closely the what we're calling the Canadian Arctic shipping region, and it's further divided by ship class. So you can see down on the bottom left there the kinds of ships. It goes into some detail in terms of the kinds of emissions. And then importantly, also it allows you to download. So you can export. You can see there all the both the criteria: air contaminant, air pollutions, NOx, SOx, carbon monoxide, etc., particulate, but then also the greenhouse gases, black carbon, carbon dioxide, methane, nitrous oxides, etc., and a number of other data points as well. So we can download that and create some assessments, and what's kind of nice is we can match them up so to the kind of ships that we're using. So just to give you that have been studied in the earlier part. So just to give you some feel for what you find when you do that. So the Arctic represents about 0.3 gigatons worth of shipping emissions, out of a total of just over 8 or 9 gigatons of emissions from shipping across the whole of all of the regions in Canada. So relatively small, but nevertheless, when you compare it to something like the Great Lakes or the St. Lawrence region, in the same order of magnitude in terms of the value of emissions in the region. You can see Great Lakes at 0.6, St. Lawrence at 0.8. So these are CO2 equivalent emissions for 29 calculated using the, the Government of Canada's standard method for 100-year global warming potential for the fourth framework from IPCC. It's worth noting that, of course, this is ships that are moving in and out of the water surrounding Canada. So Canada's domestic marine transportation emissions are between 4 and 5, or estimated to be between 4 and 5 gigatons, around 4.4 gigatons for 2019. And that's because domestic shipping is ships that go between 2 Canadian ports. So just like in the Arctic, if you have ships, international ships that come into Canadian waters or pass through Canadian waters, they're not included in the domestic transportation. So that's why 8.7 is a bigger number than 4.4. And that's true in the Arctic. Also give you a feel for the scale of the Arctic shipping emissions of just about 0.3. Nunavut territories emissions in the National Inventory Report were 0.7. And another data point for you, we calculated the emissions from diesel consumed in the Arctic for power generation in 2017 to be just under 1 gigaton. So that gives you some kind of data points for the feel for the size of the CO2 emissions impact. But CO2 equivalent is a good measure of overall emissions. So that's the kind of the context. Now let's talk about the ships in particular and which ones emit the most. So you can pull out, here's just a raw data extract. You can suck all the data out by type and all of the key pollutants. And then what we did is match them to the kinds of ships that we've been studying as part of the work and the work that VARD has done in terms of modeling typical types of ship. And there's quite a good match between the categories of ships that we've looked at. So if you summarize that, basically you see that the total, 271,000 tons of CO2 equivalent emissions is broken down in these basically ship categories. So you can see the category down the left-hand side in terms of the type of vessel. And then these red numbers here show the match to a type of vessel that we studied in the earlier tasks. And I'll go into that in a bit more detail in a bit. But bulk carriers, these are the big ships that come in and out of Canadian waters to pick up ores from the mines. And you can see that's responsible for about 62,000 tons. General cargo, those are the ships that carry out the annual Arctic sea lift, delivering goods to communities. Tankers are the ships that bring fuel to the mines and the communities, also on the annual season. And then icebreaking bulk carriers, these are the specialized vessels that collect ore and bring fuel into mines, in a specific set of mines. So that's, if you like, these three, the general cargo, tanker, and icebreaking bulker are kind of domestic commercial fleet is what we're saying. Fishing vessels, you can see an estimation based on this data says that's a pretty significant source of emissions. It's something we didn't study for this during this project, and we can go back and look at some of the reasons why we didn't do that originally. Icebreaking is also quite a significant source in terms of and you can see there 24,000, and then cruise ships is an estimate based on the tool, and then tugs and others. So you can see the breakdown of emissions there, which is the data that allows us to then start as the baseline for what the impact of switching fuels might be.
Paul, before you move on, we have a question from Karen. Is the 0.7 GT for the Nunavut territory in 2019 from communities? I think that's going back to the previous.
Yeah, so that is, whatever the national inventory report methodology is. So I had the same question, Karen. I didn't have time to look yet to see is the breakdown by province and territory comprehensive in the way that it accounts for industrial sources. I think it should, but I don't know the answer. For some reason I can only see the chat with you, Megan.
That might be a function of the way that Zoom is set
Okay,
up.
well, you just keep firing.
I will just keep relaying questions as they
All
come.
right, so that's the emissions, and of course we are showing here black carbon, the greenhouse gas emissions that make up carbon dioxide equivalent emissions, but we also of course have NOx, SOx, and particulate from those. I should hasten to add that this is only as good as the underlying assumptions that that Environment and Climate Change Canada commissioned to be put into the tool originally. So we've already spotted some issues. For instance, the baseline assumption is that some of these ships are still burning heavy fuel oil, when we know that in many cases those ships have already switched to cleaner burning marine diesel oil. So we need to take account of particularly in the case of SOx emissions or particulate, we need to make sure that the baseline is aligned with the improvements. So I'll talk about that in a bit more detail later on. So the other data source is how many ships are there actually making those emissions? So we've been very grateful to receive some data from the University of Ottawa's Environment Society and Policy Group have an AIS data and an automatic ship information tracking, sorry for the background noise, data set. And so they've been able to categorize, how many unique ships are visiting the Arctic region on an annual basis. And we've got a pretty close alignment by ship vessel type with the categories that we're using. So you can see some notes on the right matching them. There's only a couple of adjustments that we need to make to break out the specific unique ship types that we're talking about. And so when you summarize that, we've got a chart here, so you can see, so I think here we've got it by fuel consumption, which is also just a proxy for emissions, if you like. In the right-hand column, in the left-hand column, the number of vessels. So bulk carriers, those international ones collecting ore from the mines, there are about 33 unique ships that are responsible for those emissions. 17 ships carrying out the Arctic sea lift annually, 14 tankers carrying out the fuel supply emissions, 3 icebreaking bulk carriers in the fleet, 32 fishing vessels, between 6 and 8 Coast Guard icebreakers active in the region in any particular year, and I think 10 cruise ships identified. And then again, the matching to the codes that we've been using for the case examples that VAR has been conducting on the right-hand side. So that'll give us a feeling for the amount of fuel that's going to be needed if these ships begin using changing fuels, but also the investment required as well. So we've got these numbers to use. So let's talk about the implementation scenarios by each ship type now. So I'll go in sequence. This is the bulk carrier. So what VAR did is create a representative example of a ship and then studied its route that it travels and the emissions that it makes, both currently as a ship, either using heavy fuel oil currently or after the implementation of the HFO ban using marine diesel oil, and then did the same thing under LNG. So we have that as a representative example. So I shouldn't say ice-breaking bulkers, apologies. So this is so just ignore the ice-breaking bulk carrier, that should say bulk carrier. So the scenario is these international bulk carriers, instead of burning marine diesel oil, because of the HFO ban, they are converted to use LNG. We use the reference case that VAR did A7. We can calculate the emissions impact using the baseline emissions from the marine emissions inventory tool, multiplied by the factors that we've calculated in task 3. And we could look at an economic impact of what the annual operating cost savings for the companies that are shipping the goods out of the Arctic would be. We have an investment value we can calculate by the number of vessels they would need to convert to do that. And then we can also look at the amount of LNG that would be required and compare that to the LNG that's available in Europe, because these ships refuel in Europe. You can see the map here. They come typically from ports in Europe, come across the North Atlantic and call on the mines along here. So that's one case, one implementation scenario. The next two are related to the sea lift. So there's the general cargo. So these are the ships that deliver goods to the communities around the Arctic. So the implementation scenario would be to say they'd be replaced with LNG powered ships when they're replaced. And we use the data from reference case A2. Similarly, we could calculate emissions impact by factoring the benefits and the increases and decreases in emissions that we see. We could look at an economic impact in terms of the annual savings, investment required, and then we would look at the amount of fuel that they would need and compare that to the LNG that's available in Quebec, because these ships typically fuel for their voyages in Quebec, where they pick up their supplies for the annual sea lift voyages. A couple of notes there. The marine emissions inventory tool currently assumes that these ships are burning HFO, even though they're not necessarily all burning HFO already, and some of them are already using, well, some of the tankers are already using LNG. There is an issue here. We've got a couple of, in the case example, we assumed a particular kind of very lower methane emissions engines for these ships, but if they didn't use those engines, there'd be limited benefit in terms of greenhouse gas emissions. So we'll have to, as I mentioned, we're going to dive into that question a little bit. And currently bunkering, bunkering means refueling, by the way. So refueling sources for LNG ships are relatively limited currently in Quebec. So that's the general cargo ship. The tanker ship question looks very similar. I mean, those ships, instead of supplying bulk cargo, these supply fuel. So primarily diesel fuel for electricity, for vehicles, for aircraft. They deliver it into region. And so basically exactly the same. I won't go into the details, but the scenario is identical. This is the one case where we have we already have, I think, up to half a dozen of these tanker ships have already started using LNG in the Petronav fleet, owned by Groupe des Gagnés, are using LNG. So this is an example of where the fleet has already started to commence conversion. Then the ice-breaking bulker corresponds to type A6. So these are these specialist ships that can continue to go in and out of mines in the region on almost a year-round basis. I think the A6 case included a conversion of some of these ships, and we could look at what the business case for that would be and the amount of fuel that they would require in Quebec to refuel and calculate that number. So then we move on to the icebreaker. So this was case A1 that VARD calculated. You can see a typical mission that it would conduct on an annual, on a seasonal basis to escort ships and conducting the sea lift, or escorting research ships, or conducting its own missions. the scenario that VARD analyzed would be that new Coast Guard icebreakers were built with LNG fuel instead of ultra low sulfur diesel. So we could calculate what the emissions impact for that would be. We could look at some of the business case, although that's obviously quite challenging when you look at the investment case for an icebreaker. It's not purely an economic one, obviously. And then we can see what the fuel demand would be. One particular of this case is that because these icebreakers need to stay in the region for the whole season, you need to create opportunities to refuel them there. And the VAR team calculated an example how that might be done in task 4. So how you could bring LNG into the region to supply those ships. One thing to note here is that obviously these ships are typically diesel electric. That means a generator that drives, a generator is driven, and then the propellers are turned by an electric motor. And that currently limits the choices you have for engines to some of these higher methane emissions engines. So that outweighs a lot of the greenhouse gas reduction benefits. So you'll see, and we saw that in the task 3 analysis that we did, showing that when you use those kinds of engines, you get quite high methane emissions, which is one of the limiting factors on this implementation scenario. And then the final one we want to look at is the cruise ship. So again, VARD created some analysis based on a cruise ship. You can see the particulars there, and based on starting voyages in Iqaluit. These are entirely hypothetical because there isn't really a domestic cruise industry currently, and so this was to look at what would that look like if that were to start, and if those ships were fueled by LNG, they would have to be originating in Iqaluit. The reference case is A4, so we could calculate what the emissions impact would be, what the economic impact would be, and look at how much fuel they would need if they were going to be fueling from there. It does require, obviously, because the voyages originate and terminate through the season in region, they can't leave the region to get fuel, so they need to be able to refuel. But again, they're also limited in engine choice, similarly to the Coast Guard icebreaker. Their configuration means that they have generators that are powered by these smaller 4-stroke medium-speed engines, which are the ones that emit the highest methane emissions. So the CH4, the symbol for methane. So again, there's a risk associated with cruise ships switching to LNG that methane emissions could significantly increase. So those are the implementation scenarios. The fuel costs. So the fuels that they're filling up with, these are the datums that we put into the task 2 economic analysis, with one addition. Now, based on the task 4, we can calculate what the cost per ton of LNG in Iqaluit is. LNG is more energy dense on a weight basis. So if you like, 1 ton of LNG gets you further than a ton of. So these are when you do it on an energy basis, this is factored into the calculation in the business cases. I just thought I'd mention that. These are the datums that we use in analysis. Obviously, in the current world economic circumstances, these numbers have changed substantially. Roughly speaking, everything has basically doubled. So now marine diesel oil is about $1,600 a ton. Heavy fuel oil is about $800 a ton. LNG, in some cases in European spot market, because of the Russian gas prices is even 3 times higher than that. Although I'm informed that the LNG in Montreal has not had the same change in magnitude. It's our intention not to try to change any of that. So we're going to continue with the baseline datum assumption. We're going to try and react to every economic change. So the intention is to say, we'll stick with these datum figures. There is a sensitivity analysis in task 2, which allows you to see, I think we conducted up to a 50% change. We didn't take account of 100% change. But interestingly, I guess one of the impacts is when all of fuels go up, the energy cost increases in proportion to other costs, and therefore the payback periods in general are reduced. So if all fuels go up by a factor of 2, then payback periods are generally reduced. But it's obviously not our intention to try and do a detailed economic modeling assessment. This is something that ship owners and operators are doing and are making assessments of which fuels they're going to pick. If you remember, the study is intended to say, if they do pick LNG as a fuel, what is the consequences of that decision, and what are the potential benefits and risks associated with it? So VARD has updated some of the task 2 analyses with the in-region fuel costs for the icebreaker and the cruise ship. So you can see there, because the fuel is now in the region, it costs a little bit more, and so the light gray bars are higher than the dark gray bars. So they're coming closer to the current cost that these ships are incurring in terms of annual fuel costs. So reducing the cost savings, if you like, that you can see for the icebreaker and the cruise ship. So the gray bar instead of the black bar. And then also looking at the payback periods that operators might be considering when they look at these ships. You can see that it changes the payback period because obviously the energy cost goes up. So it takes longer for the savings to recover their initial investment in installing the equipment.
Paul, before you go on, I'll just note that Bruce has raised a hand. Bruce, did you have a question or comment that you wanted to raise?
Hopefully a quick question. You can hear me, right?
Yes.
I'm sorry. I've removed my video because it was chewing through too much bandwidth, and that's why I got kicked out. I'm not on my usual internet location. Paul, 2 slides back, you had various LNG costs, and you've now included the new landed or nearby Iqaluit cost. Are we also going to include the cost for potential locally generated LNG in the Northwest Territories?
I think we haven't yet. If there's interest from the group in doing that, we could add that.
I suspect it's fair to say that the locally produced LNG was somewhat more expensive than the landed in Iqaluit price. Probably
It was,
an
yeah,
important
exactly.
point to make.
Yeah.
It's probably very interesting from a local energy security point of view, but the economic case is a bit challenging.
Correct. Yeah, we could. I mean, I think probably the easiest thing to do would be we could calculate what the LNG pricing. I think we calculated in $1 per liter basis. So if we want to compare it to shipful, we could convert the Cambridge Bay case, which was case scenario 2, to dollars per ton, and basically you could infer what the change would be in terms of economics of that.
And arguably that case may be a lot less affected by global energy price changes, given that their market is not necessarily a global one.
Okay, so that's the economics. So again, these are the kinds of business cases that ship owners and operators will be looking at as they consider, for instance, what to do about the HFO ban coming into place and the choice of more expensive non-persistent fuels. These are the numbers that they would be looking at if these were the prices of LNG and MDO, their alternative choices. And I put up the sensitivity, and I say I won't go through this. This is in the chart. So in terms of the greenhouse gas emissions impact, these are still draft figures, subject to change. I should have put that on the chart. I will put that on the chart before we share it. Obviously, CO2 is reduced because there's less carbon in methane, in natural gas. Black carbon is reduced. You can see we're taking account of the baseline being heavy fuel oil for many of these categories of ships, particularly the general cargo and the tanker. Methane is increased, and it's particularly increased for this category of engines I mentioned that could be used on the icebreaker and the have to be used on the icebreaker and the cruise ship. And one risk that we will highlight is that if those kinds of engines are used in the general cargo, for instance, or the tanker, then methane emissions would reduce, would be significantly increased. We haven't calculated nitrous oxide, so nitrous is a very powerful greenhouse gas. We haven't factored into any of our calculations. It is reduced by somewhat by the use of natural gas as a fuel, but we haven't factored it into the calculation. I thought that's important to highlight.
Just noting that Andrew's got his hand. Andrew, did you have something you wanted to add?
Yes. Paul, I should clarify, the LPDF does not have to be used for diesel electric. We use the mix of engines just to show what the difference in emissions would be. But in fact, you could run these ships on the lower methane emission ships as well. There is one factor associated with the icebreakers and to a lesser extent the cruise ships that does influence this as well, which is that they spend a lot of their time running at relatively low power, which is when methane slip is more acute for any engine type. But we could have generated better results if we wanted to by assuming good engine technology, but because of the fact that methane emissions are not currently regulated, we wanted to make sure that there was a more comprehensive picture.
Yeah, that's a good point, and I guess we'll need to talk about there. It is true that there are limited choices. If you wanted to commission a new cruise ship, say with LNG, you would not have as many choices in terms of these high pressure dual fuel engines that have the lowest methane emissions.
There's a relatively small number of dual fuel engines, but there are enough that you could, if you wanted to. As I say, the real issue at the moment is because it's not regulated.
Yeah.
And under the IMO, both are treated as being essentially identical in terms of their benefits for emissions. Owners will go with the cheap one.
Yeah.
And if the cheap one on this particular day happens to be the higher emission engine, then that's what you're going to get.
Yeah. That's a good point. Thanks for the clarification. So that when you summarize, these would be the greenhouse gas impact on CO2 equivalent. If you made all those changes, if all those ships switched fuels to LNG, you'd see some greenhouse gas, CO2 equivalent greenhouse gas emissions. We have to do basically tank to propeller impact, because because we're only looking at the emissions in the region. If you wanted to see a life cycle, basically from the well to the wake, if you like, you can look in. Those are in task 3. We're doing things a little bit differently. We're including black carbon, as I mentioned. We're not calculating N2O. And I think Andrew just mentioned that if you want to get these very big greenhouse gas reduction benefits, you have to use one particular engine type. You can see the impact of using the high methane emissions, particularly in use cases where you have low loads, where methane emissions are higher. So you can see that the percent reductions are very low or even positive in the case of the potentially in the icebreaker with that particular engine choice. And I think we'll have to go into a bit more detail, as Andrew mentioned, on the impact. That you can see the significant impact of technology choice on greenhouse gas emissions reduction. But just in summary, though, you're looking at 45,000 tons or 47,000 tons, so like 20% of the total emissions in region from shipping, CO2 equivalent emissions. You can conduct similar analyses on the air pollution impact. NOx reduction, unfortunately, you only get NOx reduction when you use those same engines with the high methane emissions. So it's kind of a trade-off between NOx and methane. You do obviously get SOx reduction because there's very little or any sulfur in LNG. But actually, you're obviously getting a big benefit in switching to low sulfur versions of fuels that are going to come about potentially as a consequence of the HFO ban as that comes into play. And you do see some significant particulate reductions, and those we can calculate and we'll summarize in the report. So basically, we're multiplying the baseline by these representative case examples. Now, we will have to put a big health warning on this to say, obviously, this assumes that the case examples that VARD created are representative of all ships in each category, which they clearly are not. So we'll have to put some caveats on obviously the accuracy of this, but it does give people a feeling for the size of the potential changes that could be experienced if you were to if these ships were to change fuels. And then the last thing I have for you is just some very preliminary look at the supply chain options. So if you calculate the amount of fuel that each of these kinds of ships needs for seasons, so that's what VARD has done in each of these cases. So for instance, a bulk carrier needs 2,700 odd tons of LNG each to carry out the voyages that it would do back and forth to the Arctic from Europe. If there are 33 of them, that's going to need about 91,000 tons of LNG a season if all of them switch to LNG. So that's how you calculate these. You can see we've calculated those or will calculate those values. And then if you sum them up, so 91,000 tons of LNG in a year in Europe is quite a small amount compared to the millions of tons of LNG that are available in Europe. If you add up all the Quebec requirements, you can see 37,000 tons of LNG. If you add together the Arctic, you'll get still a relatively small. It's around I guess 0.05 million tons per annum would be the total number of. So it's smaller, I think, than the total production from Energea's current or around the same size as Energea's small LNG plant. So could be the fuel demand from these ships could be addressed with a relatively small scale liquefaction plant and a bunkering or refueling facility similar to a small liquefied natural gas jetty. And we'll go into a bit more of that scenario in the chapter. So I'll stop there. So basically what we've taken you through there is the work that goes into primarily task 7, 1, 2, 3, and 4. As I said, we are working on summarizing the environmental impacts in terms of the air pollution and health benefits, the greenhouse gas discussion in terms of the reductions, but also the risks and mitigations of increases, particularly from methane. And then we'll pull out some of the discussion on oil spill risk reduction potential from the earlier chapters. I mentioned the economic impacts. We will try our best to, as I said, turn some of these this business modeling for ship owners and operators into more sort of regional economic impacts in terms of goods transportation cost, LNG sales, infrastructure investment, ship conversion and construction costs, and if we can, electricity costs. And I will stop at that point and see if there are any further questions.
Thanks so much, Paul. That's a lot of information for
yeah, a lot
those
of
two
tables.
segments. A lot of tables and graphs.
Well, and I think he just wanted to show you the kind of the nuts and bolts in underneath what we're doing. As I said, everything is subject to change. You know, this is very preliminary, so it's more to tell you kind of what we are doing. We need to check all our numbers, and Vara working closely with us on making sure that we've got all these assumptions correct in these calculations. But that's kind of, it just gives you a feel for the kinds of calculations we're going to do, and then how we'll try and summarize that for this final chapter.
Great, thank you. So just to put out to the group here, is there anything that you think we have missed in what we're considering for different implementation scenarios that Paul covered, factors that should be considered when assessing the benefit or otherwise to the Arctic, considering things that you'd like more detail on or that weren't clear to you, recognizing that that was a lot of information to digest all at once. And if you reflect on this and have questions later, please don't hesitate to reach out to me or anyone else on the team to ask those questions. And the idea with this is to give you a chance to kind of think about it, reflect on it. If you've got questions now, we'd be happy to try and address them. If you have questions that we need to take away and work on, we will do that. If there are, then the intention is we'll have another session where we will provide some updated information, and it's again another chance for people to reflect on this information, ask questions, and make sure that we, in preparing these reports, we are covering off all of the things that people want to know, that they would need to know if they are trying to make decisions based on this information. Bruce, go ahead.
I'll also note to some of the people who are on the phone or on the line, pardon me, that the near final version of the first 6 tasks is available as a document that we can provide to you. I did send it out to a number of participants, and I will use the term prospective participants. So some of you may have colleagues who I sent an email about that to. Feel free to get back to me, and I will actually provide a copy of that if you want to look at that. It will give you more information, specific information that may be useful for some questions or queries that you may have, or particular scenarios that you might want us to think about. So just a reminder that that's available, and our intention is to provide participants in this study, that's you and others, all of you on the phone or on the line, pardon me, with that ability to see all of the work that's gone into this thus far, and all of that information that will roll up. And as you can see from the presentation that Paul has provided, there's a lot of layers of information that you can unpack. So do contact me or Megan, and we'll make sure you get a copy of that if you want to take a look at it.
I've just put my email address in the chat. Bruce has been having some issues with his email, so just to make sure we sidestep any of those, just feel free to contact me and I'd be happy to share a copy of that with you, and we'll make sure that you get it as soon as possible. I am seeing a hand from Jeffrey. Jeffrey, go ahead.
Thanks, Megan. Thanks for your presentation, Paul. That was very informative. I apologize. I was on the call. I was on the phone because I was having some connectivity issues, so I wasn't really able to participate closely with the presentation. That being said, I guess my general question is, in terms of the economic impacts, what level of analysis has, I guess, this report or this work or research has done on other sectors or cross-cutting sectors, such as mineral exploration development potential in the territory? I mean, some of the immediate things that I can think of, I think we're currently at a sort of a phase 1 with the Baffinland Iron Mine project is currently, I guess, precariously operating. Future diamond mine potential in the Baffin through De Beers, current nickel and gold and zinc projects that are happening in the territory. I think those are all obviously economic drivers that we consider when we're looking at, I guess, the cost and benefit of something like this. And I'm wondering if that was taken into consideration in terms of the analysis.
I'll unmute myself. The only contribution that we can offer or through the scope would be the landed cost of LNG. So we mentioned this, there's a scenario in task 4 where it says if you imported LNG into the region and compare that to the price of diesel, so that could be used as our community fuel, but of course it could be equally well applied in a mining or any other industrial activity, for instance. So that's a very good benchmark, if you like. I think all of these business cases for these would look at LNG. We could look at the price. There's also, as Bruce mentioned, another scenario that says producing LNG in the region and then distributing it, and it shows what the cost of that fuel would be. Because the scope of this is marine LNG, that's kind of the intention is to say, well, that's in scope because we're delivering it in an LNG ship. So, but I don't think we have or will be able to go on to say what the impact of using gas instead of diesel would be in terms of for those projects. That being said, we are aware that there are significant feasibility studies that have been taken, and in our task 4 working groups, we were made aware of a number of studies that have been done for gas as a fuel, as an alternative to diesel for a number of mineral exploration projects. They tend to be kind of proprietary studies, but I think the key public benchmark you would get would be price of diesel, and that would show you what the kind of potential economic benefit would be. Bruce, it sounds like you wanted to add something to that.
Yeah, I think the challenge with some of these speculative and sort of questions about how this affects economic development, I think Paul is absolutely right. We are able to generate a landed LNG price. We're able to increasingly develop a local LNG price. I think that becomes very interesting for communities that are looking at economic development opportunities, if for no other reason than there for multiple fuels, possibly even local fuels to consider. That's not really the scope of the study from the perspective of Transport Canada. It certainly becomes a little bit more interesting for my organization and for other organizations that have a greater interest in LNG and natural gas in particular. So that there may be some of those organizations that will want to riff a little bit on that. And there's certainly a basis for some additional conversations outside of the report, but we do want to capture some of that flavor. And so it sort of becomes an intangible narrative. It's very difficult for us in operating a project like this to kind of include a speculative mine project or something like an economic development project. We, at an earlier, more ambitious phase in the work, wanted to reach out to some of these organizations and some of these potential projects. They're interested, I think, but they don't often have the bandwidth to also take this kind of a task on. And then, as Paul also mentioned, a lot of what they do is proprietary, so they wouldn't want to share some important details with us when it comes time to try and figure out what the economic benefit is. So rather than do a bad version of economic benefits, we were trying to kind of keep to scope, but certainly for organizations in the region that are interested in those opportunities, this study will be a good tool and will be helpful. And outside of the study, we would be happy to put you in contact with some of our study participants and others who might be able to carry those conversations further forward. And this, of course, this work will be available for communities to kind of go back to and reflect on as projects possibly come online. That often will have a shipping component. So I think we'll have some other benefits that come from the project being here, and I think that's why it increasingly becomes useful and worthwhile for organizations in the region to kind of have eyes on the project and participate a little bit as we finish it up.
No, thanks. I appreciate that response, Bruce and Paul. Obviously, we're looking at sort of the economic scope of this report, sort of in the bubble of marine shipping, and I understand that, but that also does provide some limitations in terms of the opportunities to, I guess, to limit the economic impacts if the government of Canada does choose to move this route. And I think when NTI is working with the government of Canada and working with the government of Nunavut on whether that's energy or infrastructure or marine shipping or what have you, we really do like to take evidence-based approaches that take a holistic view of Nunavut's economy. And I think that's sort of our preferred method when we're looking at these types of issues and reports, if you will. So we do see a lot of merit in looking at Canada's commitment to wean Nunavut off diesel by 2030, or not. And you mentioned these in the report, but the IMO reports to get off or limit carbon and emissions by 2029. So these are important factors for us. The Nunavut the Nunavut mining industry does contribute to a large portion of Nunavut's economy. So does the Nunavut fisheries in terms of investing back into the territory for economic development or infrastructure development. So these are important factors for us, recognizing that this is a marine study. I think one thing that was somewhat noted in the report that I do need to flag is that actually it wasn't referenced in the report, but the report looks at servicing, I guess, companies, marine shipping industry that's outside the territory, servicing the territory. So there's a lot of economic leakage there when it comes to looking at future potential opportunities for transitioning to LNG. So that's something to keep in mind when we're observing the future challenges, if you will, and retooling to a different fuel as we move forward. And I guess closing, one last thing I will say, I don't want to take up too much time here. NTI still does need to work with the government of Nunavut in terms of cooperating more closely on our transportation strategy and our energy strategy. I think those two documents are getting long in the tooth from 2001 and 2007. Fortunately, we have an opportunity through our NTI-GN partnership agreement to work on things like energy, things like infrastructure, things like conservation. So it's a good opportunity for us to be at least well aligned in terms of our future needs and goals for energy needs for the territory. I guess I'll leave it at that, and thank you for your presentation.
Thanks so much for those comments, Jeff. Does anybody else have any questions or thoughts or areas that they'd like to raise that could be considered or should be considered, or that they'd like clarification on, or an assumption they'd like to make sure we really dig into and test? Anything that was raised as part of the scenarios or use cases? And again, I'll mention if you do want a copy of that report, just let me know. I'd be happy to share what we've got to date with you. And also, I'll just add that if you know of anybody who would be interested in hearing more about this report, or you think should be part of these discussions, we would appreciate if you could let me know or put us in touch with them. And in addition to these sessions, we can also, for anybody who's missed today, we can set up another meeting or another opportunity to hear their feedback and discuss any questions that might be part of this content. As we want to make sure we capture as many perspectives as possible as we go through the finalization of the material.
Hi, Megan. It's Jeff here. In your original invite, I did invite our regional Inuit associations as well. They play a sort of a big role or key role in terms of our governance of our Inuit organization. So hopefully for the July 5th meeting, some of them can participate in the call. I noticed in the report that Kivalliq Inuit Association did participate in some of the engagements and consultations, which is great, but there are two other Inuit organizations and associations that I think could potentially make a contribution.
Thank you, Jeff. That's really great. It's there's always more than we are aware of, and it's great to have your support in helping track down the people who really we would like to have their input on all of this material. So thanks for sharing that. And again, hopefully they can either take part in the July 5th meeting, or if that doesn't work out, we'd be happy to try and set up something separately, a date that does work.
Megan?
Yeah, Bruce.
Yeah, I'm going to pick up on that last point. We are open to and willing to organize one-on-one sessions with organizations or people who have questions. There are some limits to the possible. We have, and Megan's going to remind me, I think we have about 4 weeks left before we need to have completed version. Is that right? My math is failing me.
Yeah, that sounds about right, Bruce.
And perfectly occurring in a time of year when many people will like to take vacation. So we will try our best to arrange one-on-one sessions if we need to, if there's a request to do that. We can also take feedback through email. We will do our best to touch base and speak with as many groups as we can. Again, recognizing there will be some limits on how many millions of hours we can spend on this. But we also have the other session as another opportunity, which has been formally organized. So we're encouraging those who are here to pass on comments to colleagues and to kind of give us some feedback as and when they can. And we will reach out to anyone that has been missed if people bring those organizations and those individuals to our attention. And we will do our best to get as much perspective as we can. I also mentioned that, when the document is complete, it will be a document that will be available for organizations and others to use. And so we hope that the baseline data and the key information will also be useful and helpful. And so if there are other implementation and benefit scenarios that develop, they can, even if we haven't captured them in this document. So thank you all for joining. I know we're probably getting close to the end of the time, so I thought I'd better, if I'm going to gab, I'll say that too. Thank you to Clear Seas for organizing it, and I'll pass it back to Megan to close us out.
Yeah, as Bruce noted, we're right at the end of our time now, so we'll wrap up. And a couple of people have asked if they can get a copy of the presentation, and yes, that is something that we can do. We will be posting on the Clear Seas website the material that Paul shared, and I think, Paul, we can probably send out a copy of slides.
Yeah, why don't we email? I've just made a PDF. I just put some draft things. I'll put a PDF copy. We could email it to the participants today as well.
Yeah, so I'll send that out by email today so that everybody can see, go back and dig into the various graphs. And if you do have questions after you've had a chance to digest them a little bit more, please do let us know. We'd be happy to try and answer any questions that come up from that. I know it's sometimes hard to fully ruminate on all of it as it flashes past on the screen. So thank you all so much for your participation today and your attention and questions, and look forward for some more information coming out from me shortly. And then we hope to speak to you all again on July 5th. And as we mentioned before, if you know of anybody who should take part or would be interested in taking part, please do share the information with them and encourage them to sign up. Thanks all for taking part. Have a great day.
Thank you.
Everyone.
Thank you. Bye.